Have you ever found yourself, sitting on a project or maybe a career move, and you're just entirely paralyzed because the environment isn't perfectly right?
Oh, absolutely. It happens all the time.
Right. Like you tell yourself you're just waiting for the friction to clear. You think, you need a more stable market or better equipment or just a more predictable timeline before you can actually begin.
Yeah, you convince yourself that starting a complex task in a chaotic environment is basically setting yourself up for failure.
Exactly. So you just wait. But that distinction between waiting for the friction to clear and actually using that friction to gain traction, that's the core of what we are analyzing today. Welcome to the deep dive.
Glad to be here for this one. It's a really fascinating topic.
We've got our hands on a highly specific, very strategic workshop document. It's titled Engineer 4.0 Roadmap from Maysan to the World. And the target date for this session is Tuesday, April 21, 2026.
Which is incredibly specific.
It is. And our mission today, what we're extracting here, is essentially a masterclass in bypassing environmental constraints.
Right, because the author argues that before we can even talk about engineering machines or networks, we have to talk about engineering minds.
Yeah, it's a complete shift, moving from just hoarding technical knowledge to, you know, aggressively applying it under less than ideal circumstances.
And to really understand the weight of that argument, you have to look at the architect of this roadmap, Dr. Mustafa Sadiq Latif Al-Jumaili.
His background is pretty incredible, right?
It really is. His authority on this subject doesn't come from abstract theory. It's entirely empirical. I mean, he started his career in 2007 as a student at a local Iraqi university.
And from there, he eventually engineered his way to earning a PhD at the University of Tennessee, Knoxville.
Exactly.
Which is just a staggering leap across totally different educational and infrastructural realities.
It's massive. But the most compelling data point is his digital footprint. The document notes that from literally a small room with a computer, he built the Mustafa Sadiq Scientific Channel. Yeah, we are talking about over 1,900 specialized videos, reaching more than 95,000 subscribers. Plus, he's published over 70 Arabic articles and 20 English research papers.
That's a serious body of work.
Right. His expertise covers ICT, networks, and embedded systems. So when he stands in front of a room in Maysan and tells engineers how to reach the global stage, he's handing them the exact blueprint he used to build his own bridge.
And the foundation of that blueprint relies on a concept he calls operational hope, or in Arabic, al-amal al-tashkili.
What's fascinating here is how Dr. Mustafa diagnoses the modern crisis for engineers in a place like Iraq in 2026.
Yeah.
Because the bottleneck is no longer access to information.
Right, the internet shattered that barrier decades ago.
Exactly. The actual deficit is this operational hope. He defines it as a deep structural belief that a technical solution is possible.
But it's not just a belief, is it?
No, it's permanently paired with the immediate initiation of work. It means you do not wait for ideal laboratory conditions.
Just start.
Yeah, you begin compiling the code or sketching the schematic or building the prototype with whatever resources are currently in the room.
Okay, let's unpack this for a second, because he draws a really sharp contrast with the alternative, which he brilliantly terms the rust of minds.
Yeah, the rust of minds. It's such a visceral image.
It really is. Think about it like a surfer. If you're a surfer and you wait for the ocean to be perfectly flat and predictable before you get in the water well, you're never going to surf.
Right, you have to learn to ride the chaotic waves.
Exactly. If you think about an engine left sitting on blocks in a humid environment, it doesn't just stay stagnant, it actively degrades. The metal oxidizes, the pistons seize up.
The problem-solving muscle literally atrophies.
Yeah, if a technical mind sits in a state of negativity, waiting for the macroeconomic storm to pass, it literally loses its capacity to solve problems.
Because the chaos of a developing context isn't blocking the engineering process. The chaos is the design parameter.
But wait, hold on. Is it really fair to tell engineers not to wait for ideal conditions when they might be lacking basic infrastructure?
Yeah.
I mean, if I'm an engineer operating in a region where the electrical grid goes down unpredictably for several hours a day, my mind isn't rusting. My servers are literally powering off.
That's a very fair point.
So how does Dr. Mustafa reconcile this demand for operational hope with the stark reality of missing physical infrastructure?
Well, he reconciles it by pointing to local empirical data. The document does not gloss over the infrastructural deficits at all. It actually highlights them to prove that constraints force novel engineering.
Oh, really? How so?
The text specifically details the success model of a local Iraqi engineer who bypassed those exact grid limitations. This engineer developed localized energy solutions using only simple, accessible capabilities.
So they didn't have access to some massive R&D facility.
Exactly. They didn't have a perfectly stable national grid. They used what was right in front of them, like maybe decentralized microsolar setups or highly efficient embedded systems with really low power draws to solve the problem locally.
That's incredible.
They succeeded specifically because they refused to let the lack of a macro solution stop them from building a micro solution.
So operational hope, in practice,
Hmm.
means treating the broken grid as a variable in your equation, not an excuse to close the textbook.
Precisely.
That completely reframes the responsibility. The environment isn't an excuse, it's just a constraint. And engineering is literally the science of operating within constraints.
Right.
So once an engineer adopts this operational hope, what are they actually building? The document uses electromechanics as the model to introduce the concept of Engineer 4.0.
Yeah, and this is where we see the death of silos.
The death of silos.
Yeah, historically, engineering was strictly compartmentalized. You had mechanical engineers who understood gears and fluid dynamics. You had electrical engineers for power distribution, and software engineers writing the logic.
Everyone stayed in their own lane.
Right. But those isolated lanes are dead. The successful modern engineer, as outlined for 2026, is a cyber-physical systems engineer.
Meaning the physical machine and the digital network are no longer separate entities.
They are entirely fused. Dr. Mustafa illustrates an engineer in Mesan who is utilizing the Industrial Internet of Things, the IIoT.
Oh,
They aren't just designing a standalone mechanical pump for a southern Iraqi oil facility. They are connecting that physical heavy machinery directly into cloud networks.
wow.
Yeah, pulling operational data like pressure, temperature, vibration, and digitizing it in real time to optimize the refinery's output from a remote dashboard.
And the document notes they're using generative AI to design these systems, right? To simulate complex mechanical faults and even write the control codes.
Yes, they're using AI to model a catastrophic failure in an oil pipeline digitally thousands of times before a single pipe is even laid in the dirt.
Here's where it gets really interesting, though. If an engineer in 2026 relies on generative AI to write the control codes and simulate all the physical faults, aren't we looking at the rapid erosion of their core competency?
I mean,
Well, if the AI is generating the logic that runs the physical valve, the engineer is essentially reduced to a prompt writer. Don't they lose their fundamental understanding of the mechanics?
see, that anxiety assumes the value of an engineer lies in syntax and manual calculation. The roadmap argues the exact opposite.
Okay, so what's the argument?
The AI and the IoT are livers. If you give a construction worker an excavator, you don't worry that they're forgetting how to use a shovel, right?
Right, you expect them to move a mountain instead of a mound of dirt.
Exactly. The AI handles the rote generation of the code, but the AI lacks physical intuition. It doesn't understand what a latency spike actually means when it's communicating with a high-pressure steam valve in a physical refinery.
Ah, so the human engineer has to understand the physical consequences of the digital logic.
Precisely. The value of the cyber-physical engineer is in systems architecture. It's their ability to orchestrate that convergence.
That makes total sense.
The AI might write the script, but the human sets the safety constraints, understands the environmental variables like, say, extreme heat in southern Iraq affecting sensor reliability, and ensures the digital command translates safely into mechanical action.
So you aren't replaced by the AI, you're promoted to managing the ecosystem the AI operates within,
Exactly.
which obviously requires a massive level of high-order thinking. But here's the next problem. Having that high-level cyber-physical skill set in a local market is basically useless if no one in the global market knows you exist.
Right.
To move from Maysan to the world, you have to prove your competence.
Mm.
Which brings us to the section on digital identity, specifically regarding LinkedIn.
And if we connect this to the bigger picture, this is where the roadmap transitions from technical philosophy to immediate tactical execution. Dr. Mustafa states very clearly that LinkedIn cannot be treated as an electronic CV.
Okay, so what is it then?
It must be utilized as an impact lab.
An impact lab. To put that in a different context, think of a traditional CV as a storage unit. It's just a flat list of the paints and brushes you own. I have a degree, I know Python, whatever, just lists the raw material sitting in your inventory.
Right. It's very static.
But an impact lab is like an art gallery. You aren't listing your parts, you're displaying the finished painting for everyone to see. You're proving the structural integrity of your knowledge, actively working under load.
That distinction is exactly why the workshop outlines 3 very specific tactical steps for building this impact lab.
What's the first step?
First, students are instructed to stop simply listing their graduation projects as bullet points. They must transform them into published case studies.
Okay, so going deeper than just a title.
Right. They need to articulate the original problem, the methodology used, the constraints faced like those power outages we talked about, and the actionable solution they engineered.
Because a case study proves you understand the why and the how, not just the what.
Exactly. Now, the second step is to proactively map and engage the local industrial network.
Meaning what exactly for these engineers?
For these engineers, that means identifying and connecting with the massive oil, gas, and construction firms actively operating right there in Basra and Maysan. You don't build a network in the abstract, you build it where the capital and the infrastructure projects actually reside.
That's really practical.
Yeah.
And then there's the third step, which is reaching out to global experts using value-based messaging.
Yes, and this is the critical mechanism for crossing from the local to the global stage.
But let's look at the mechanics of that interaction. If you are a newly graduated student from a regional university in Iraq, and you're trying to message a senior global expert in Houston or London, why would they even read that message?
It's a huge hurdle.
The asymmetry of power and status is massive. Calling it value-based messaging sounds great, but practically, how does a student offer value to an expert who already has decades of experience and infinite resources? Doesn't that just trigger massive imposter syndrome?
It sounds impossible if you approach the interaction as a transaction where you're asking for a favor.
Right.
If you message them saying, I am a recent graduate, please look at my CV, can you give me advice? You are creating work for them. You're an unknown variable asking for the most valuable asset, which is their time. That is a static CV mindset approach.
So how does the Impact Lab change that dynamic?
By shifting the engineer from a requester to a provider of localized data, value-based messaging means your outreach is rooted entirely in your operational hope and your case studies.
Give me an example of what that looks like.
So you message that senior expert and say, I read your recent paper on optimizing flow rates in heavy oil extraction. I took your theoretical framework and applied it to my localized case study regarding a specific facility in Maysan, compensating for intermittent grid power using embedded IoT sensors. Here is the data set I generated.
Wow. That completely changes the polarity of the interaction. You aren't asking them for a job, you're literally handing them a field test of their own theory in an environment they don't have access to.
Exactly. You are offering peer-level engineering insight. You are proving your competence through action.
Even if the experiment didn't work perfectly.
Yes. Even if your experiment failed, providing the data on why it failed under specific environmental constraints in southern Iraq is incredibly valuable to a global expert.
Because it's real-world data.
Right. And that instantly dissolves imposter syndrome because
Yeah.
you aren't pretending to be anything. You're just sharing the verifiable work you have already completed.
You're entering the room with a working prototype instead of an empty hand. That is a masterstroke in networking. And what becomes abundantly clear as you read through these tactics is that this workshop is not just, a passive transfer of information. It is highly engineered to trigger a specific outcome.
Yes, if we pull back and look at the broader architecture of this document, the true mission of the session reveals itself.
Which is?
This workshop is an initial announcement, sure, but more importantly, it is a filtration mechanism. Dr. Mustafa is using this roadmap to identify and select elite candidates for something called the Mustafa Sadiq Fellowship.
So it's a dedicated pipeline to forge the future technology leaders of Iraq.
Exactly. And you do not find elite, action-oriented leaders by just giving them a lecture and letting them walk out the door.
So what does this all mean? Well, it brings us to the concluding exercise of the roadmap. And this is arguably the most fascinating part of the entire document.
Oh, definitely.
After laying out the philosophy of operational hope, the convergence of cyber-physical systems, and the mechanics of the Impact Lab, the workshop does not end with a polite Q&A. It ends with a mandate.
It demands immediate, verifiable execution. The final instruction requires the attendees to create their LinkedIn account right there in the room if they don't already have one.
Right then and there.
Yes. They must immediately write a 3-line post summarizing their personal vision for Maysan's tech future, and they must publicly tag Dr. Mustafa Sadiq.
It forces the attendee to collide with the rust of minds in real time. I mean, think about the friction of that moment. If you're sitting in that room Your instinct is to say, oh, I'll do it tonight when I have time to craft the perfect paragraph, or I need to take a better headshot first.
I need ideal conditions before I can publish.
Yes, all those little excuses that disguise themselves as preparation. But by demanding a three-line post immediately, the workshop strips away the illusion.
It really does.
It forces unpolished, bold action. If you wait to write the perfect post, you demonstrate that your mind is still rusting, and you literally filter yourself out of the fellowship. You prove you are not ready to be Engineer 4.0.
It is the ultimate litmus test for operational hope. Are you willing to initiate the work right now with whatever raw materials are currently in your head and put it on a global server?
Exactly.
The engineers who push post are the ones who understand that the messy, imperfect launch is infinitely more valuable than the flawless theoretical idea that just stays hidden on a hard drive.
So we have tracked an incredible trajectory through this roadmap today. We started by dismantling the illusion of perfect conditions, identifying how waiting causes a literal decay of our problem-solving abilities, that dangerous rust of minds.
Right.
We saw how operational hope flips that script, demanding that we use our environmental constraints as the very parameters for our engineering. We explored how this mindset prepares an individual for the realities of being a cyber-physical systems engineer, where the physical world and digital AI networks blur together into one continuous feedback loop.
And we also unpacked the mechanics of taking localized skills to a global market. We saw how transforming a static resume into an active impact lab, built on case studies and value-based messaging, allows local talent in Mason to offer genuine utility to a global expert anywhere on Earth.
And finally, we saw how all of this theory culminates in a single, unavoidable demand for immediate action. So, as we wrap up, I want you, the listener, to apply this filtration mechanism to your own professional life. Look closely at the projects you've stalled, or the career pivots you're delaying, or the problems you claim are just too complex to tackle right now.
It's a tough mirror to look into.
It really is. Where are you standing on the runway, waiting for the friction to disappear, refusing to use it to generate lift? Where is the rust of minds quietly degrading your capacity to build? And what is your version of that three-line post? What is the smallest, messiest, most immediate action you can take today to initiate the work?
This raises an important question about the future of our professions, really. When we look at the roadmap for Engineer 4.0, we see a world where generative AI, machine learning, and automation are rapidly taking over the syntax of coding, the simulation of faults, and the raw mechanics of technical design. If the machines are increasingly capable of executing the technical how, will operational hope, that human courage to look at a constrained, chaotic environment, believe a solution is possible, and simply take the first imperfect step, eventually become the only truly essential engineering skill left?
That is a staggering thought to carry with you. In an ecosystem where AI provides the infinite leverage, the human has to provide the immediate momentum. You do not need a flawless environment to begin. You just need to refuse to let your mind rust. Start building your impact lab, push the imperfect code, and we will catch you on the next deep dive.